So first we're going to try to answer the questions in the pre-lab exercises. So if you have dealt with chemical formulas before, you know that they are often written like this. Let me grab a piece of paper so I don't have to write in my lab book. So for instance, you can have a formula like H2O, which is water, or copper SO4, or potassium sulfite. So these subscripts show how many atoms of a particular element are found in a single molecule of a compound. So when you look at water, it consists of 2 atoms of hydrogen and 1 atom of oxygen. You look at copper sulfate, it consists of 1 atom of copper, 1 atom of sulfur, 4 atoms of oxygen. You look at potassium sulfite, it consists of 2 atoms of potassium, 1 atom of sulfur, 3 atoms of oxygen. So this is why we need subscripts. So far make sense? Yes, it shows how many atoms are present in a single molecule of a compound. The next question is pretty simple. What is the total number of charges in an ionic compound? This right here is an example of ionic compound. And the ionic compound is neutral. Okay, potassium per se, so if 2 atoms of potassium each carries a charge of plus, and the sulfite anion carries 2 minus. So what you have 2 pluses. Check this out, look, you have 2 pluses and 2 minuses. So the total number of charges in the ionic compound is 0, because 2 plus and 2 minus cancel each other out. Good? So the naming of ionic compounds. In ionic compounds, and I'm going to give some examples. So in ionic compounds, like this 3 that I illustrate here, well, I'm going to throw in one more. You need to identify a cation and an anion. So these are cations, and these are anions. And you name it, first you name the cation, sodium, and then anion. In this case it's chloride, sodium hydroxide, sodium sulfate, potassium phosphate, copper sulfide. You have to appreciate that the names, like the name of anion matches the name of an element. The name of cation, so the name of cation matches the name of the element, sodium, potassium, copper. However, the name of anion, which is negatively charged, you just have to memorize those, and there's going to be a list of anions that you have to memorize. Let's move further and let's answer the question, why should a chemical equation be balanced? We're balancing chemical equation for proper calculations of the excess reagent, or how much of each reagent we need for the reaction to run, or what's going to be the yield of the reaction. The left side of equation, and let's say you have an equation like this. I'm going to actually throw in an actual one. So the left side of equation here represents the reactants, while the right side of equation, that's the question number 6, represents the products of the reaction. Now, next question is, what happens in a combination reaction? The good example of combination reaction will be burning of carbon, burning of coal, where carbon combines with oxygen, producing CO2. So in combination reaction, two reagents, they form a single compound. They combine to form a single compound. And the question number 8 asks about the reaction between magnesium, this reaction right here, reaction between magnesium and hydrochloric acid. And you can see that in this reaction the gas that bubbles off is hydrogen. Okay? Now if we go to experiment 8D, which I believe may be a little premature, okay? So we add 3 drops of 1 molar sodium hydroxide. Okay, so this is how much sodium hydroxide from that question is added to the copper sulfide. Now, next question is, water is decomposed and one gas is double in quantity compared to the other. What is the smaller gas in terms of volume? Now look at the reaction of water decomposition. So look at this. You have 2 molecules of hydrogen. You see that? This first coefficient shows not how many atoms, but how many molecules. So 2 molecules of water, when decomposed, produce 2 molecules of hydrogen and 1 molecule of oxygen. Therefore, you have oxygen is the smaller by volume gas in the mixture. Any questions on these questions, essentially?
Yeah, I think for number 7.
Yes.
Combination reaction, I know is when the 2
In combination reaction, 2 reagents,
reagents come together to form one. product.
One product, yeah. That would be it. That would be it. That's very good.
And then for number 9, I didn't get that one. How much NaOH?
It's not, number 9 is not particularly great question. 3 drops of 1 molar sodium hydroxide.